Namaste and a very good morning to all of you. I welcome you to my channel, The Outlier. In today's presentation, we'll be looking at Statcraft P. Now, what is Statcraft P? Statcraft P is a web-based solution for data science with Python. The front end for this particular tool is a GUI, which I'll be showing in a few moments from now. And at the back end, we make use of Python codes. I'll be using a case study, and through a case study, we can explore different features of Statcraft. In this particular slide, we will be covering three major items. One is, what is the objective of the case study? This case study is on component failure detection using machine learning. I repeat, this case study is all about component failure detection using machine learning. What is the data that we have? Data contains information like machine conditions and usage, the failure history, and machine features. Thirdly, what techniques will we be using in this case study? We'll be mainly using the Heatmap, followed by Anova, and thirdly, random forest classifier. So these are the techniques that we will be using: Heatmap, Anova, and random forest classifier. To proceed with the case study, as I just now mentioned, this case study is on component failure detection using machine learning. The data, we have already seen some of the important variables, but let me just open the spreadsheet and show you what is this data set all about. As you can see here, this is the data set that we have. We have information about timestamp. We have machine ID, important parameters like voltage, rotation, pressure, vibration, age of the component, and finally, which of the four components has failed. For example, if you study the first record, the information about the machine with the machine ID 1 was collected at 1st January 2015 at 6 o'clock. Different parameters corresponding to the machine like voltage, rotation, pressure, vibration, and age of the component is given. And finally, we have one important variable, that is failure. And here it says component 4 experienced failure. In the second row, you have component 1, which has experienced failure, component 2 in the third row, so on and so forth. We can use this particular variable as the dependent variable, and the remaining variables like voltage, rotation, pressure, vibration, age as the independent variables. But even before this, let us just look at the objectives that we have. One of the first objectives that we have is to find out the relationship between various parameters of the machine. To perform relationship analysis between various parameters of the machine, let me take you to Statcraft. This is a web-based tool. Let me provide the login credentials. Only those people who have the appropriate login credentials will be able to access this particular tool. The moment I give the login credentials, you can see the landing page. This is how the main page looks like. You have a blank sheet with the columns being called as variables, and the rows here are called as cases. To access the file, what I'll do is I'll click on the view button, go to source. We have component failure data set here. This is the data set which I was showing you earlier. We have got all the variables that it pulls out for analysis. We are all set to analyze the data. To answer the first objective, what I will do is I will click on the analysis button. Here, I will choose the option graphics. Once I click on the graphics menu, you can see 10 different options being highlighted. Now, out of all these different charts, what I'll do is I will choose the last graph, namely heat map. Once I click on heat map, you can see a new window popping up. Now here I can specify various parameters like voltage, rotation, pressure, vibration, and age. These are the 5 variables for which I want to see intercorrelation. Let me click on the option OK. Statcraft quickly runs the analysis and produces the output in the output window. This is the Python code that it has run at the backend to generate the heat map. And as I can scroll down, you can see here the heat map appears. These numbers that you see lie between 0 and 1, and values which are negative indicate that there is a negative relationship. And if the value is close to 1, it means that there is a positive relationship between the variables. To interpret this heat map, what I will do is I'll take you back to the PowerPoint. This is the objective. The technique that we have used here is heat map plot. This is the output of heat map. And to the right side, you can see all the variables and the respective correlation coefficients. What is the inference that you can draw from this? There are 3 major inferences that we can draw. First, as the voltage increases, the rotation of the component is reduced or decreases. Why do we see this? Look at this particular value, minus 0.025. This is the value between voltage and rotation. And since it is negative, we say that voltage and rotation share an inverse relationship between each other. As voltage increases, rotation of the component comes down. Let's look at the second point here. As the age of the component increases, the pressure starts decreasing, which implies that older machines, as the age of the component increases, as the machines become older, the pressure start decreasing and the voltage and vibration start increasing. The third point here is, as the rotation increases, the vibration of the component decreases. This is because rotation and vibration share a negative relationship between each other. What are some of the benefits of this particular heat map? To understand the benefits of heat map, let me take you through to the next slide. We have performed the heat map, and through the heat map, we've been able to arrive at some important conclusions. The benefits here are that we have been able to find out the relationship between different components and how they are affecting each other. So we can control the parameters to avoid change in other components. So this is the first major benefit of objective 1. With this, I will move on to the second objective. Here we will be using inferential statistics. What is objective 2 all about? Here we are interested in finding out if there is a significant difference between failed components and voltage supply. I repeat, is there a significant difference between failed component and voltage supply? What technique we will be using to address this particular objective? The technique that we will be using is Oneway Anova. Why Oneway Anova? Remember, we have 4 different components which have experienced failure. If we had only 2 components, we would have used independent samples t-test. Because we have 4, we will be using Oneway Anova. To perform Oneway Anova, I will go back to Statcraft. Let me show you the data once again. This is the data editor window. Here, I can perform Oneway Anova. Let me click on the Analyze button. Within the Analyze button, the third option is Compare Groups. You can see the option of Anova. Let me click on the drop-down menu. You see the first option under Anova, which is Oneway Anova. Once I click on this, a new window pops up. I have to supply the variable that I'm interested in analyzing. The variable here is volt. The category which I will be using for analysis would be failure of the component. Now, once you specify the variable and the category, you can click on OK. In a few moments, what Statcraft does is, in the output window, it shares the code that it is running at the backend. This is the Python code that is used to analyze this, what is the impact of voltage on the failure of the components. And this is the Oneway Anova table. To interpret this table, what I have done is I've taken this particular table and pasted this in the PowerPoint slide. You can see here, this is the same Oneway Anova table that Statcraft produced. You see some important variables. If you're a statistical expert, you'll be interested in degrees of freedom and sum of squares. If you take the sum of squares and divide it by the degrees of freedom, you should be able to get the mean square. The ratio of the mean squares will produce the F statistic, and the probability value is computed for F statistic. As you can see, the probability value is 0.51. What conclusion can we draw based on the p-value? Remember, the p-value lies between 0 and 1. So what is the conclusion that we can draw? The conclusion is, from the ANOVA table, we have a p-value which is greater than level of significance. Hence, we conclude there is no impact of voltage on failed components. So voltage does not have any bearing. It does not have any impact on failed components. So this is the interpretation of one-way analysis of variance. Let's move on to the benefit. What is the benefit that we have been able to pull out through Oneway Anova? The benefit is, from Oneway Anova, we conclude that voltage has no impact on failed components. With this, I will make a move on to predictive analysis. We started off with exploratory data analysis, that is EDA. We moved on to Oneway Anova, which was an example of inferential statistics. Finally, what we have is predictive analysis. Here, the objective that we have is to make a prediction of component failure using a machine learning algorithm. We are trying to predict which component would experience failure through a machine learning algorithm. What is the technique that we will be using to make this prediction? The technique that we will be using to make this prediction is random forest classifier. To perform random forest classifier, I will take you to Statcraft. This is the Statcraft output that we had produced earlier. Let me click on the data button. To perform random forest classifier, at the top left-hand side corner, you see the analyze button. What you can do here is choose the option machine learning. You see a whole lot of options here. We see around 10 different options corresponding to machine learning. I will choose the option random forest classifier. Why random forest classifier? Because the dependent variable here is a categorical variable. Since our dependent variable is a categorical variable, therefore, we choose this particular technique. What are the independent variables that we need to specify? We can specify voltage, rotation, pressure, vibration, and age of the component. You can tweak some of these parameters. I will leave it at the default setting. You have the option to experiment with different features here. What I will choose is to save the predicted values and the predicted probabilities. I want to predict which component experiences failure and what is the probability of a particular component experiencing failure. I'll choose OK here. Once I choose OK, as before, you can see all the libraries that have been installed in Python, the data frame, how have you been able to create, and the algorithm. You see some description about feature importance. For each variable, we are able to see the feature importance. And as you can scroll down, you see the component, for each component, what is the confusion matrix and the overall accuracy being displayed here. More than this, what I am currently interested in would be the predicted values and the predicted probability. So let me show you the data and take you to the last two variables. You can see predicted values here. Our random forest classifier has predicted that component 4 will experience failure, and this is the probability with which we are able to predict that component 4 will experience failure. So there's a 76% chance that component 4 experience failure. The second row, there is a 77% chance that component 1 experiences failure. There is an 85% chance that component 2 experiences failure, 69% chance that component 4 experiences failure, so on and so forth. Now, to look at the output and the quality of the model that we have been able to produce, let me go back to the PowerPoint. This is the feature importance table that Statcraft had produced. You see different parameters and the corresponding importance here. Looks like pressure, voltage, and vibration are the most important variables which drive component failure. The importance of pressure is 22%, voltage is around 21%, and vibration is 21%. So pressure, voltage, and vibration put together explain around 60% plus reason for failure of this particular component. Going further, you can see here, this table talks about the overall accuracy of the model. The earlier table was all about the feature importance, where we identified which are the most important factors which are related to component failure. We said pressure, voltage, and vibration are the most important factors which are related to component failure. Here we are saying about the overall accuracy. The overall accuracy is close to 100%. Now, 100% could be because our model is overfitting. That could be a possibility. I will not speak about the problem of overfitting in this particular case study, but nevertheless, at a very high level, you can look at some of the important metrics like what is the precision, what is the recall, what is the F1 score, so on and so forth. Finally, what are the benefits that we have been able to obtain through a random forest classifier? Now, through a random forest classifier, we've been able to identify the failed components. And because we have been able to identify the failed components, we can take immediate action on the failed components to avoid failure of the entire system and thus reduce the cost of failure. So with this, I come to the end of today's presentation. We have looked at 3 different objectives. We have looked at 3 techniques, namely Heatmap, Oneway Anova, and random forest classifier. We have looked at the benefits of each of these techniques. And thus, if we have to do any case study on component failure, Statcraft is a great tool which helps us very quickly run analysis. You don't have to keep any codes in mind. You don't need too much of training. It has a friendly GUI, and therefore you will be able to concentrate more on the analysis part and less on the programming part. I thank you very much for joining me today. I thank you very much and have a very, very good evening.